Hi, good morning. It's nice to be here again. All right, it's a bright morning. We have a good weather here, and today I'll be going through the second paper. That's the A-level mock exam. Finally, I'm able to do this video. Right. So yeah, I'm going to start from the first question. This question, most of my students didn't get it right, so I'm going to try to explain it. It says the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time it left. All right, it says the results are given by this, then use it to estimate the length of the runway. So this is how it works. At time 0, the speed was 2. At time 5, the speed was 5. At time 10, the speed was 10. At times 15, the speed was 18. At time 20, the speed was 28. So what we need to find is what distance was covered. So we have to estimate the distance. This is not accurate though, it's just an estimation. So we have to do, just a second. So we have to find what is the distance covered between 0 and 5. That will start as our distance 1. The one covered between 5 and 10, that will start as distance 2. The one covered between 10 and 15, distance 3. The one covered between 15 and 20, distance 4. The one covered between 20 and 25, distance 5. So we'll add them together and that will give us our estimate for the length of the runway. So let's rock and roll. So for the first one now, this is number one. Number one A. So we know now that the estimated distance is going to be the addition of S1, S2, S3, S4, and S5. So that's according to what I explained here. So we need to find what is S1. For S1, we are moving with these variables. The initial velocity is 2, the final velocity is 5, the time taken is 5. So if we use the formula S equals ut plus rvt squared, no, we do not have acceleration, so we can't use that. We can use v equal to, we can use S equal to u plus v. Yes, and that will work perfectly. So if we use S equals u plus v over 2t. Yeah, good. So in this case now, we know that our initial velocity is 2, our final velocity is 5, and the time taken is 5. So we have s equals 2 plus 5 over 2 into bracket 5. So if we do this, this should give us 7 over 2, that's 35 over 2, which should be 17.5. That's for S1. Then for S2, we have the initial velocity, this time is 5, and the final velocity is 10. So what we are doing is to find the distance covered from time to time, and the time taken there was from 5 to 10, that's 5 seconds. So we have 5 plus 10 over 2 into bracket 5. And when we do that, that's 15 over 2, 75 over 2, we should have 37.5. Then we can find S3. I'll put that here. We can find S3, which is going to go from 10 to 15. Our initial velocity this time is 10, while the final velocity is 18. So we have 10 plus 18 over 2 multiplied by the time is 5. Good. So this gives us 28 over 5 over 2 times 5. That should be 14 times 5, and that should be 70. Then the next one, which is S4, we're going to have the initial to be 18, the final to be 28, and the time taken is 5. So we have 18 plus 28 over 2 multiplied by 5. So if you add 18 to 28, that should give us 46. 46 divided by 2 is 23, multiplied by 5, that's 115. So let's see. For S5 rather, S5, it's going from 28 to 42. The time is also 5. So that will be 28 plus 42 over 2, 5. So that will be 28 plus 42 should give us 70. 70 times 5 is 350, if you divide it by 2, that should be 175. Please, you can confirm my answers. Just trying to do them. Then we add them together. So the estimated distance, is going to be 17.5 plus 37.5 plus 115 plus 70 plus 175. So I wrote it down somewhere. So I should be able to give us the answer. That will be 415. Yes. 450. So we have 17.5, 37.5, 115, and 175. Good. So the estimated distance, which might not be the actual distance, but just an estimation, is 415. Then the second question says that given that the jet accelerates smoothly in these 25 seconds, so that means it accelerates smoothly. There's no interruption in the acceleration. The plane didn't have to, I mean, the jet didn't have to apply brake, if that makes sense with jets, anyways. So it says that explain whether your answer in part A is underestimate or overestimate. That you want to check if the answer in A is overestimated or underestimated. So since they use the word that the jet accelerated smoothly, it means that the increasing in speed is gradual and smooth, which means if it is increasing 3 from here, it's going to maintain that rate all through the journey. So it won't be like this is difference of 3, this is difference of 5, this is difference of 8. No, it's going to maintain 3, 3, 3, 3, 3, 3. So if you try to estimate the distance for that, it's going to be lower than when it is jumping from 3 to 5 to 8 to I think this one is 10, and then this one should be 14, I think. Yeah, 14. So this is not accelerating smoothly. So if we are considering the fact that it is accelerating smoothly, then the rate is going to be the same, which means that at the end, it won't get up to 42 meters per second at the end of 25 seconds. So which means that our answer should be an overestimate. So the answer for B, 1B, is overestimate. All right, so let's see second question, which is number 2, says, so we have a function g of x, which is equal to 2x plus 5, x minus 3, then it has a condition that x has to be greater than or equal to 5. All right, it says we should find gg of 5. So gg of 5 is saying we have two functions. The first one is put into a second one. Yeah. So we need to find what g of 5 is normally. So g of 5 should be 2 times 5, 10, plus 5, 15. And 2. So how did I get that? G of 5 is wherever you see x in g of x, put 5 there. So that will be 2x, which is 2 times 5. That makes it 10 plus 5. That's 15. Then at the denominator, you have 5 minus 3, which is 2. So that means this gives us 15 over 2. So that will be g of 15 over 2 now. Then you put the 15 over 2 back into g of x as well. All over 15 over 2 minus 3. And this should give us 20 over 9 over 2. So you can confirm those answers. That should be 40 over 9. All right, so let me check as well. Yeah, 40 over 9. 40 over 9. That's good. Then the second one, which is the B part, it says that state the range of G. State the range of G. So remember we said G has to be greater than or equal to 5, which means, okay, let me write it out. X has to be greater than or equal to 5. We want to find the range of G, that is, our G of X is going to be moving from what value to what value. So I will say put the least value of X. The least value of X in this is 5, because we said X has to be greater than or equal to 5. So the lowest X can be is 5. So let's try and see G of 5. I think we did that earlier. G of 5 gave us 15 over 2, which is actually 7.5. So I want to see something. If I continue to increase the value of x, what happens to g of x? Is it increasing or decreasing? So I'm going to put x equal to 10 to see that. I want to check. Now, the least value of x is 5, but if I decide to increase the value of 5, I mean the value of x, I want to see what will be the trajectory of g of x itself. So I'll try to put 10. So g of 10 is going to give me 2 times 10, which is 20, plus 5, that's 25. over 7. 25 over 7 is 3 point something. Okay, so if I decide to put 20 as well, so I'm going to have 45 over 17, which is going to give me 2 point something. So it shows that the higher the value of x, the lower the value of g of x. Please, I hope you got that. As you increase x, g of x reduces. Now, I need to know what should now be, how low will g of x go to? I mean, how low is it going to go to? How low is it going to get? And how do I get that? I'm going to try to do what we call limits. I'm going to find the limit of g of x as x approaches infinity, because if x is increasing, and the question says x is greater than or equal to 5. So that means x continues to increase infinitely. So that means x is approaching infinite. So if I say the limit of g of x as x approaches infinity, so I'm saying the limit of 2x plus 5 over x minus 3 as x approaches infinity. Please pay attention to this. I'm not sure if this has been taught in pure math. It should be, but let's hope, let's just assume that it is not. So we need to find how to do it. So what you do for you to find the limit as x approaches infinity is factorize x out at the numerator, factorize x out at the denominator. So in this case, x is going to cancel x. So you have limits as x approaches infinity, not equal to 9 of the limit of 2 plus 5 over x over 1 minus 3 over x. So the way limit works is that it goes into those numbers one after the other. If you do the limit of 2, it gives you 2. Then you have the limit of 5 over x. If you do the limit of 1, it gives you 1 because it doesn't have any x with it. Then you have the limit of 3 over x. So what you are saying is that as x approaches infinity, what will be the behavior of 5 over x? As x approaches infinity, what will be the behavior of 3 over x? So note this. The higher the denominator of a fraction, the lower the value of the fraction. I will use two ways to explain that. The first way is what I'm saying now. The higher the denominator of the fraction, the lower the value of the fraction. I'm saying 5 over 6 is bigger than 5 over 8 because the denominator is higher now. So the higher the denominator, the lower the value. So if I keep on increasing the denominator, because that's what 5 over x is, I'm increasing the denominator, and I keep on increasing it, the value of 5 over x is going to continually go towards 0. It's going to be approaching 0. So the limit of 5 over x as x approaches infinity is 0. The limit of 3 over x as x approaches infinity is also 0. So as a matter of fact, the second way which I want to explain is, as a matter of fact, if you do the limit of 1 over x as x approaches 0, it should be 0. And let me show you why. If you have 1 over 0, any non-zero number at the numerator and you have 0 at the denominator, it's going to give you infinity. Or if you put it in your calculator, it gives you undefined or math error, right? So if I decide to do a cross multiplication, then I'm going to have 1 over infinity equal to 0. So if you do a direct substitution of x to be infinity, you see that it's 0. So this part now becomes 2 over 1. So what it's saying is that the limit as x approaches infinity of this is equal to 2. So that means as you increase x to infinity, this guy is going to approach 2. So the least it can be, in fact, it won't get to 2. Now, the way limit works is that x will never get to infinity. So which means that thing is not going to get to 2. So you cannot count till you get to infinity. Infinity is not a number, it's a concept, it's to represent infinite. That is a part of which you cannot get to. So if you are doing this now, we know that the highest value of g of x is 7.5 because we observe that when we put the lowest value of x, we got 7.5, and the higher the value of x goes, the lower g of x goes. So the highest value is 7.5, and then how the worst place it can be is 2. So this shows that the range of g of x is simply 2 is strictly less than g of x, less than or equal to 7.5. It's not going to get to 2, but it's going to get to 7.5, and that will be the answer. So with that, you have your mark. Then normally it's not going to be that long, right? I know it's 1 mark and you feel like, do I have to do all of this? No, you don't have to show all of this. I'm showing it because I'm explaining it to you. Right? So let's see for C now. C says that find G inverse of X and state its domain. So C. So normally G of X equals this. If you want to find G inverse of X, you say let Y be equal to G of, so that you have Y equal to 2X plus 5 over X minus 3. And the next thing will be for you to make X the subject, because you want to find the inverse. You make X the subject. So you have Y into bracket X minus 3. That's me doing a cross multiplication. Or you say multiply both sides by X minus 3 equals this. So you have Yx minus 3y equals 2x plus 5. And then you put the x together. So I want to change this to xy. So you have 3y plus 5. If you factorize out x, you have this. So what you do now is you change your x to G inverse, and then you change your y to x. So this is the inverse. So remember, we are to find the domain of G inverse. The domain, now let me say something. Inverse function is like the opposite of a function. If G of X moves from domain to range, G inverse of X is going to move from range to domain. It's like you are traveling from Coventry to London. That's G of X. G inverse of X is your return journey from London back to Coventry. The same road, the same way, right? But your starting point is different. So the starting point here is called the domain for this. The ending point is called the range. And for the inverse, the starting point is called the domain. The ending point is called the range. And this is because a function and its inverse are both functions. The inverse G inverse of X is also a function. So if you are asked for the domain of this, you just need to go and pick your answer for the range of this. They are the same. They are the same. If you are traveling from Coventry to London, that is G of X, and you are returning backward, you are now coming from London. So where you ended the first journey is where you are starting the second journey. So I'm saying the domain is the same answer we got before. The domain is 2 less than or equal to X. No, 2 less than X, not less than equal to. 2 less than X, less than or equal to 7.5. That's the domain. All right. So let's move on. Um, Okay, I think that's the end of number 2. So let's go to number 3. Number 3, we have a sequence, and then we are asked to show that the sequence is periodic. So I'm going to put it up. Question 3. Question 3A. So we have A1 equal to 3, AN plus 1 equal to 8 minus AN. All right. Okay, so we want to show that it's periodic. So how do we do that? Let's try to find the terms of the sequence. So if A1 is 3, let's try to find A2. Now do you find A2 when you put your n equal to 1? If you put your n equal to 1, you get A1 plus 1 equal to 8 minus A1. So that means A2 equals 8 minus A1. A1 is 3, so which is 5. So A2 is 5. Then let's try to get A3. How do you do that? Put your n equal to 2. So you see that you have A2 plus 1 equals 8 minus A2. That's saying 8 minus 5. You got your A2 to be 5. So that means A3 equal to 3. So if you continue, you realize that the sequence is going to look like this. A1 is 2. A1 is 3 rather, sorry. A2 is 5. A3 is 3. A4 is 5. Then you continue to have this. And this is how we know it's a periodic sequence. Since it is repeating the same function, it is periodic. A periodic sequence is a sequence in which the term follows a regular pattern, repeating itself. So you have 3, 5, 3, 5, 3, 5, 3, 5. Then let's see. This says state the order of the periodic sequence. So the order of the periodic sequence is how many times does it go before it repeats itself? How many times does it go before it repeats itself? 1, 2. It goes two times and then it repeats itself, so it is order 2. It's a periodic sequence that has order 2. All right, let's see. This one says now find the sum. That sign is summation sign. It says find the sum from 1 to 85. So you have this n equal to 1, not a. N equal to 1 to 85 an. So this, what it literally means is that your first term, add it to your second term, add it to the third term, add it to the fourth term, continue the addition till you get to the 85th term. All right. So if you look at this now, that means we are doing 3 plus 5 plus 3 plus 5, and then we continue like that till we get to the 85th one. Now, looking at it, the 85th one should be 3. How do I know? Study the pattern. A1 is 3, A3 is 3, A5 is 3. For every odd places, it is 3. A2 is 5, A4 is 5. For every odd place, even places, it is 5. So if I decide to pair them up, this, this, the next two, I will realize that I'll be adding 8 because 3 plus 5 is 8 together 42 times. Then I'm going to add 3. How did I get that? Divide 85 by 2, you get 42 with a remainder of 1. So that means if I pair them up, I'm going to have 42 pairs with a remainder of 1. The remainder of 1 is going to be the 85th term, which is 3. So if I had 8 42 times, it means I'm doing 8 times 42, then I'm adding 3 to it. So 8 times 42, that's 6 remainder 1, 336 plus 3. So that means my addition now, n equal to 1 to 85 an, is going to be 339. That's it. Okay, let's move on quickly. So we move to number 4. The laptop is draining really quick. All right, we move to number 4. I think we should still be able to get to number 6, number 7 before I have to cut the video. So we move to number 4 now. It says given that this equal to this, show that. So let's write it out. So A, I think. Yeah, it says given that 2 log 4 minus x equals log x plus 8. So we have to show this quadratic equation. So let's see. So first thing is to use laws of logarithm, which is whenever you have a power, or let me put it out, whenever you have this, it's the same as bring what you have behind, bring it forward, and it becomes power. Oh, sorry. Okay. Bring it forward, and it becomes power this way. So we're going to do the same thing for this guy. So it becomes log 4 minus x raised to the power of 2 equals log x plus 8. So the same way, if you have two logarithmic functions equal to themselves, they have the same base, you can equate what you have in front of the logarithm. So you have 4 minus x cos squared equal to x plus 8. So if you open up, if you expand this one, it becomes 16 minus 8x plus x squared equals x plus 8. So you have x squared. If you try to simplify it, if I bring everything on the right side back to the left, you have x squared minus 9x plus 8 equal to 0. So let's see, is that what they want us to get? Yeah, that is it. So we have our 3 marks. Then the B part says, write down the roots of the equation. Write down the roots of the equation. So let's see. 4b. The root of the equation means I will just have to factorize this guy. The factors here should be minus 1 and minus 8. So if I do that, I should have x minus 1, x minus 8 equal to 0, and then I have x equal to 1 or 8. So that's B1. Okay, let's do B2. 4b2. So 4b2 says that state which of the roots in B1 is not a solution. Okay, so looking at it, 4 minus x, the one that won't be a solution will be the one that gives us a negative value in front of the logarithm. And if you look at 1 won't give us, because if you do 4 minus 1, that's 3. But if you look at 8, if you do 4 minus 8, you get minus 4. We cannot simplify a logarithmic function that has negative value in front of it. So that means that, okay, so just say put x equal to 8. You have 2 log minus 4 equals to log, what's that? X plus 8, that's log 16. This is impossible. It implies that x equal to 8 cannot be a root. Yeah, and that's okay. So some roots that do not work for the function, we call them miscellaneous roots. Yeah, we used to have them where they don't work for it, but you just have to get them. We call them miscellaneous roots. So that's the answer for that. Now we can move to number 5. Number 5. All right, says the table shows this, and these. Use trapezium rule. Okay, this is interesting because a lot of my students made mistake in this, and I want you guys to really pay attention. The mistake all came from how you found the value of h. How you found the value of h, that's where the mistake came from. So I'm going to show you. Let's put it here. So number 5. I think we can start out a new page. So normally we have how many? We have this is 1, 2, 3, 4, 5. We have 5. Yeah, we have 5, right? So normally our trapezium rule, the integral of, let me just say trapezium rule. I'm going to do it for 5. It's supposed to be half h into brackets. The first value plus the fifth value plus 2 into brackets every other value. So I've tailored these to just 5 values because that's what we are dealing with right now. All right, so now we need to get our h. There are 2 ways you can get your h. You can get your h looking at it. How is x increasing? Just do the difference between 2 values of x. So 3 and 4.5, now it increased by 1.5. If you notice, each value of x is increasing by 1.5. So with that, you can get the value of your h. And if you don't want to use that, you can as well use h equals the last value minus the first value divided by how many differences, not how many values, how many differences. That is 1, 2, 3, 4. Or you say the number of terms minus 1. 5 terms, right? Subtract 1 from it. That's 4. And that's it gives you h equals 1.5. So now we can do our trapezium rule. It says from 3 to 9 of log 2x base 3 dx is going to be half of 1.5. Y1 is 1.63. The fifth one is 2.63. And then you have 2 into bracket y2, which is 2. You have 2.26. Then the fourth one is 2.46. So you can put this directly in your calculator. And if you did it very well, I'll just read out the value I got when I was doing it. Please, you should check it in case the value is not correct. So if you did it well, you should have 13.275. So let me see. Yeah, we were told to approximate. No, okay. It says to 2 decimal places. The values of y are given to 2 decimal places, so we can also approximate this to 2 decimal places. That will be 13.28, and that's the answer. So now let's see the B parts. The B one says now we're having it raised to the power of 10. So that's number 5, right? Says we should integrate this 2x to the power of 10. So remember what we did with indices the other time. We are going to do it here as well. There is a power, you throw the power backward so that you have integral of this 10 log 2x base 3 dx. That's from what I explained to us while I was in was it number 4? Yeah, this law. Yeah. So you can push the power backward, all right? So the same way here. And then when you have this, integration allows you to bring out constants that are coefficients. So you have this. Do you remember you've done this in A? So that means your answer for B should be 10 multiplied by what you got in A, which will be 132.75. So that's the answer for that. Then for B2, we have log 18x base 3. So we want to integrate from 3 to 9 log 18x dx base 3. So this as well, we are going to use indices. So I'm going to write this out as this. Integral from 3 to 9 log. So I'm going to do it as, since we have 2x, so I'm going to bring 2x out of it. That will be 9 times 2x dx. So there is logarithm. What we are doing here is logarithm firstly, not integration. We do logarithm, then after that we do integration. There is a law in logarithm that says if you have this, it's the same as this. So you can take it backward as well. So that's the same thing I want to use for this. So which shows that the integral from 3 to 9 log 18x base 3 dx is going to be log 9 base 3 plus log 2x base 3 dx. So I splitted up 9 times 2x. And when you do that, you're going to have integral from 3 to 9. Log 9 base 3 is going to give you 2. And how did I get that? Log 9 base 3 is going to be the same as log 3 raised to the power of 2 base 3. Then you transfer the 2 backward to be log 2, 2 log 3 base 3, which this is 1. So this is going to give you 2 plus log 2x base 3 dx. So integration can go into each of them. So you have integral of 2 dx plus integral of log 2x base 3 dx. So if you look at this, the integral of 2 dx is going to be 2x, and then it's going from 3 to 9, while we've gotten the value for this before. So this now is going to be put 9 into it, minus put 3 into it. So this one is for the first one. So if you do 18 minus 6, that's 12, and then if you add 12 with that, that should give you 25.275. All right? I think that's right. Yes, that is right. So we have 25.275. All right, let's see the next question. That's question 6. All right, question 6 says, show that AD is parallel to BC. So I would like to firstly write out the vector for each point. That's the A part. I want to write out the vector. So A is 12i, B is 16j. So let me just use that to distinguish. Then C is 50i plus 136j. 50i plus 136j. Then D is 22i plus 24j. 22i plus 24j. Yes. So it says show that AD is parallel to BC. So I need to get the vector for AD firstly. AD is going from A to D. So you have to do vector D minus vector A. So vector D is 22i plus 24j minus vector A minus 12. So if you do this subtraction, you're going to have 10i plus 24j. Then the second one is BC. You also find BC, and BC is C minus B. C minus B, we have 50i plus 136j minus B, which is 16j. So we're going to have 50i plus 120j, all right? So if you do this, this should be 5 into bracket 10i plus 24j. So since we are able to establish that BC is the same as 5 times AD, once you can put a vector as a multiple of the other vector, then they are parallel. So this implies that AD is parallel to BC. That's it. Sure. The box is just saying that I've shown the requirement. All right. So as soon as you're able to put a vector as the multiple of the other vector, then you've proven the requirement. So that is 6a. So let's move to 6b. 6b. Okay. Sorry. So 6b says that point A, B, C, and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all four sides of the track. Okay, the length of the sides are measured in meters. Calculate the that a particular runner that takes exactly 5 minutes completes two laps. Okay, calculate the average speed of the runner. So it says given that, okay, that's good. So we need to find the total distance. Yeah, the time taken to cover one lap. And I'm going to highlight a mistake that most people made. Most of you did you calculated the distance, right? Yes, then you divided the time 5 minutes by two to say that it's going to cover one lap in 2.5 minutes. It doesn't work that way. That a runner covers two laps in 5 minutes does not mean that it's going to cover one lap in 2.5 minutes. What if it was moving at a higher pace during the first lap and he covers it in a less time? Or what if he was moving at a higher pace in the second lap to meet up and he covers it in more time? So what you do is we find the distance for one lap, which is going around the quadrilateral, and then we multiply it by two to find the distance for two laps, and then we use it to get the average speed. All right, let's see. So if it forms, let's try and draw the quadrilateral. We don't know if it's a rectangle or a trapezium, whichever. We just know it is A, B, C, D. You can label it whichever way, but just make sure that it is A, B, C, D. Like not A, C, B, A, then D. No. A, B, C, D. Let it follow the same way. All right, so that means I need to get what length AB is. So let's go back. Have I found AB? No, I haven't. So I'm going to do that, which is B minus A. And that will be, my B is 16J minus 12J, 12I. So if I want to find it, not just AB, I'm going to find the magnitude. So that will be square root of 16 square plus 12 square because I'm finding the distance. So if I do that, I wrote it somewhere. My AB, okay, I didn't write out the value here. So I'll just write the value. Okay, so this gives me 20. Then if I want to find BC, I think I found BC already, which is 50 I plus 120J. So that'll be, if you're doing the magnitude, that'll be square root of 50 squared plus 120 squared. So this should give you 130. Then I need to find CD, the magnitude of CD. I don't think I've found that. That'll be D minus C. And if I do D minus C, that'll be 22 minus 50. That should be minus 28. 24 minus 136. That should be minus 112. All right, so if I do the magnitude of this, that should be square root of, just a minute. So that'll be square root of 28 squared. Yes, okay, so this is going to give me 115.447. So I'm just going to put it like that. Then I need to get AD as well. the distance of AD. So I already found the vector AD, 10I plus 24J. So if I do the magnitude of 10I plus 24J, it should give me 26. These are Pythagoras triplets, and that's why these two, BC and AD, that's why I could tell what value it's going to give us. So now the total distance for one lap is going to be the addition of these guys, plus 130 plus 20. And if I do that, I should have 115.447 plus 26 plus 130 plus 20. And that gives me 291.447. So now for 2 laps, it's going to be 2 multiplied by that. So I have answer multiplied by 2. That's going to give me 582.894. So this is the total distance to cover if you are going to run 2 laps. Now, let's see average speed. Average speed is total distance covered, which is 582.894, divided by total time taken, 5 minutes. However, how do they want us to leave the answer? So let me put meters here and then minutes here. So let's see, they want us to put the answer in kilometers per hour. Kilometers per hour. So we need to change the one at the numerator to kilometer. That's by dividing it by 1000. Let's give us this. And then the one at the denominator, we convert it to hour. That's by dividing it by 60. So if you calculate this, I think we should have 0.582894. Okay. Yeah, we have 6.994728 kilometer per hour. So let's see. Says give you your answer in kilometer per hour. Yeah. So if you want to approximate it to nearest, they didn't ask us to do that, but in case you want to do that, that'll be 7 kilometer per hour. And that will be the answer. All right. Let me just put it here. That's the answer. That's for 6B. Now let's see for number 7. 7, we have figure 1 is the graph. The height of the ball above the ground, h meters, has been plotted. And this is, so they want us to find the equation that connects h and x. So if this is the graph, this is a curve. Now let's see some of the things given to it. It says the ball reaches a maximum height of 12. So that means the maximum height here at this point, this is 12. And then hits the ground 40 meters. So that means this point is 40 because the distance from here to here is 40. So it shows that the root, looking at the way the curve is, it's a quadratic graph, first things first. And second thing is that the root of the equation would have been 0 and 40. So if you have the root of an equation and you want to find the quadratic equation, you just need to have, like if you have x equal to a and you have x equal to b as the root of equation, and you want to find the quadratic equation, just do it this way. X minus a is 0, x minus b is 0, and then you multiply these two together. So the same thing we are going to do here. So we have x equal to 0 and then x equal to 40 as the root. All right. So if I want to find the equation, I will have to put them in a way. Now, for the one of x equal to 0, I am not sure if there was nothing beside x. I mean, maybe we've had something like 5x equals 0, and then at the end we have x equals 0. So I'm not sure if that is the case. So because of that, I'm going to put a constant. Right, it won't come off. So I think just take that. So I'm going to have ax equal to 0. Why for this I have x minus 40 equal to 0. So I'll multiply the two. So this is how it must have been while we were solving. So this will be the equation for A. So the next thing now is at maximum. I want to find the maximum. At maximum, dx is equal to 0. So what we'll do is we differentiate the function to give me 2x minus 40a equal to 0. So we equate that to find the value of x. So you can Since a is a constant, you can divide through by a to have 2x minus 40 equal to 0. Then you have your x equals to 20. Then you come back to h. Remember, this is what we got for h earlier. You come back here and then you put your x equal to 20, because at x equal to 20, which is the point where it is maximum, h is 12 according to the question. It says the maximum point is 12, like the maximum value, the maximum height it reaches is 12. So you have 12 equals 20a into bracket 20 minus 40, which is going to give us 20a into bracket minus 20. So you have your a to be equal to 12 over minus 400. And I think that should be minus 0.03. That will be the value of h, which shows that our h now is the equation connecting h and x. Remember, it is ax into bracket x minus 40 is minus 0.03x now, because our a is minus 0.03 to bracket x minus 40. And that is the answer for h. That's for 7a. Now we need to do 7b. So now we go to 7b. 7b. So it says use your equation to find the greatest horizontal distance. It said the ball passes over the bar of a set rugby post that is perpendicular to the part of the ball. The bar is 3 meters above the ground. So we are saying h is 3 meters. We want to find the value of x that produces h to be 3 meters. So let's check. Okay. So we want to find the value of x. Now, 7b, now it says the ball passes over the horizontal, then the ball is 3 meters above the ground. So we want to find the value of x that produces a vertical distance of 3 meters. So we come here, h is 3, and then we want to find what value of x is going to be. So I need to check something quickly. 3 meters, h is measured in meters. Good. So let's see. So you have 3 equals negative 0.03. So I might just need to open up the bracket now. So this is going to give me plus 1.2x. All right. So I'm going to have negative 0.03x squared plus 1.2x minus 3 equals to 0. So I want to try to multiply by 100 so that I have minus 3x squared plus 1 to 20x minus 300 equals to 0. Then I want to divide through by minus 3 to have x squared minus 40x plus 100 equal to 0. All right, so if I solve this, am I able to 25 and more? Okay, I think I will have to use formula. So x is minus b plus or minus square root of b squared minus 4ac over 2a. So we have x equals minus 40 plus or minus square root of minus 40 squared minus 4ac over 2a. So this should give us x as, if you finish it up, you should get 2.68 or 37.32. So it's saying that the greatest horizontal, so the greatest is going to be 37.32 meters. And that'll be the answer for this, for B. All right, now let's go to C. C says give one limitation to the model. The limitation we're going to have is neglecting hair resistance. Now, this is a model. This is not real life. A model is done in a confined environment. So if you are talking about the real life, there will be hair resistance. So the limitation here is that hair resistance is neglected, which means that it's not going to cater for the fact that the ball might slow down in movement. The ball might not move as far as 40. Or if you want it to move as far as 40, you might need to increase the projecting force, which is going to increase the initial velocity. So the limitation is that um, there is a neglection of air resistance. So that will be the answer for C. Do I need to write that out? So let me just put it here. Neglecting air resistance. So we'll move on to number 8 now. Number 8. All right. I think after number 8, maybe I'll just take a break and then use that time to quickly charge my laptop. I'm on 36% right now. All right, says find the derivative of this. So let's write out f of x and g of x firstly. F of x is e raised to the power of 4x squared minus 1. And then g of x is 8 ln x. All right, so it says find f of, okay, we need to differentiate now. F prime of x means we should differentiate f of x. So if you want to do that derivative, you don't need to go ahead and, because it's just 1 mark, you don't need to stress yourself saying you want to do substitution. This is how you do it. Differentiate the power. If you differentiate 4x squared minus 1, you get 8x. Differentiate the power, then repeat the function itself. Differentiate the power, then repeat the function itself. So you have 8x, then you have e raised to the power of 4x squared minus 1. That's for A1. And then for A2, your g of x, your g prime of x is going to be, if you differentiate ln x is 1 over x, so that will be 8 over x. Right, so let's see. Given that f prime of x equals g prime of x at x equal to a, show that x equal to alpha rather, show that alpha satisfies this equation. So let's see. We need to equate both of them. F prime of x is being equated to g prime of x. That's going to be 8x e raised to the power of 4x squared minus 1 equal to 8 over x. So the first thing I will do is divide by 8. Then the second thing is multiply both sides by x, so that I have x squared e raised to the power of 4x squared minus 1 equal to 1. And if I do this, okay, I think I might have to divide by x squared again to have this. Yeah, to have this. Then, okay, I want to do something. I will take natural logarithm of both sides. If I do that, I should have ln e raised to the power of 4x squared minus 1 equals ln 1 over x squared. And then you move this to the back to have 4x squared minus 1 ln e equals ln 1 minus ln x squared. So if you have division, you can split them up. So if you do this, ln e is 1, so that means you have 4x squared minus 1. And then in this case, ln 1 is 0 minus, then the power of x here, you can push it backward to have 2 ln x. All right, so that's going to give us 4x squared plus 2 ln x minus 1 equals to 2. So I think that's what they want us to show. Then it says the iterative formula of this is used with x1 equal to 0.6. Find the approximate value for alpha. All right, let's see. That's 4b. Okay, 4c now. Not 4. I mean 8c. 8c. So I will need to write out the iterative formula first. Equals square root of, we have 1 minus 2 ln x, 1 minus 2 ln x n over 4. 1 minus 2 ln x n over 4. All right. So that we have x1 is 0.6. So here you will need your calculator. I've done the values here, so I'll just use my values that I've gotten here, and then we continue. So here we have, says find the approximate value for alpha. So it says calculate, giving your answer to 4 decimal places, x2. We need to find x2 firstly. So if you are finding x2, you put your n equal to 1. That makes x2 equals square root of 1 minus 2 ln 0.6 over 4. And when you do that to 4 decimal places, so it should be approximately 0.7109 to 4 decimal places. Then for second one, we want to find alpha. When you want to find alpha, you repeat the iteration a lot of times. you go as long until you have two consecutive values that are exactly the same to four decimal places. When you round those values to four decimal places, they will give you exactly the same answer for the two values. There won't be difference. The two of them will give you the same answer. That is when you stop. So if you continue this, I will just write out my values. I got x3 to be 0 points. So I did my values to 6 decimal places so that I'll be able to round it to 4 decimal places. Then x4 gives you 0.682121. X5 gives you 0.664593. X6 gives you 0.673979. X7 gives you 0.668884. X8 gives you, okay, so I think I continued, I didn't write that here. I continued till I got to X13. X13 gave me 0.670676. Then I went ahead to X14. X14 gave me 0.670622. Now observe, if I approximate these two to four decimal places, I am going to have the same answer. So that is when I say I have the value of alpha. So alpha is 0.6706. And that's it. You continue the iteration until you have two values that are the same to your degree of approximation. All right. I think I should still be able to do one more question. Some 30 now. So I'll do number 9. Let's see. Number 9. So it says show that cos 3a equals 4, not equal, equivalent to 4 cos cube a minus 3 cos a. Yeah. So we want to show this. When you want to show, you have sides. So I represent this as left-hand side and then right-hand side. So my left-hand side is cos 3a. I'm going to split it up to cos 2a plus a. So remember that cos a plus b from trig identity can be written as cos a cos b minus sine a sine b. So the same way, my cos 3a, which is the same as cos 2a plus a, I'm going to write it as cos a, cos 2a cos a. Let me write it well. Cos 2a cos a minus sine 2a sine a. All right. So also know that cos 2a, now we are trying to see that everything is in cosine. So whatever I'm doing, I'm trying to make sure that everything is in cosine. So my cos 2a can be written as 2 cos squared a minus 1. This is from trig identity. And my sine 2a can be written as 2 sine a cos a. So this is going to be um 2 cos squared a minus 1 cos a minus, then my sine 2a, I change it to 2 sine a cos a sine a. So if you open the bracket here, you're going to have 2 cos cube a minus cos a. That is cos a multiplies 2 cos squared a, that's 2 cos cube a. Cos a multiply 1, that's cos a. Minus, then sine can multiply sine to have 2 sine squared a cos a. So remember, what we are doing is still cos 3a. All right. And this, I can, okay. So for sine squared a, remember there is a trig identity that says sine squared a plus cos squared a is equal to 1. So from there, if I make sine squared a the subject, I'm going to have it as 1 minus cos squared a. So I'm going to bring it here. So you have 2 cos cubed a minus cos a minus 2 into bracket 1 minus cos squared a cos a. So I have changed my sine squared a to 1 minus cos squared a. So moving on, I'm going to have 2 cos cubed A minus cos A. Then I allow the minus 2 to go in. Minus 2 times 2, 1 is going to give me minus 2. Minus 2 times minus cos squared A is going to give me plus 2 cos squared A. Now, I should not forget. Oh, I almost forgot. I should not forget that, okay, there is cos A outside this one. So I'll also use that to expand it. So you have 2 cos cubed A. Now, I put plus here because I already effected this minus on what is inside the bracket. That's why I put plus there. So you have minus cos A. Then if you allow that cos A to come in now, this will become minus 2 cos A plus 2 cos cubed A. So remember what we are doing is cos 3A. Then I can add them together now. 2 cos cubed A plus 2 cos cubed A. That is 4 cos cubed A. Minus cos A minus 2 cos A. That's minus 3 cos A. This is what my left-hand side has given me. Then remember that right-hand side is the same. Let's see. Yeah, 4 cos cubed A minus 3 cos A. So my right-hand side is 4 cos cubed A minus 3 cos A. This implies that I've been able to show that my left-hand side is equal to my right-hand side. And that's it. I have shown the required. So let's see the next one. Hence, solve for minus 90 degrees less than or equal to x less than or equal to 180 degrees, the equation. Now, if they use the word hence, using the word hence means that we are to continue from what we did last time. We are to continue from where we stopped last time. So we have B 9B. So we want to do 1 minus cos 3x equals sine squared x. My laptop is low, so I think I have to just stop here for this one. Then the next video, I'm going to start from 9B. Just need to quickly charge a bit. All right, it's been an awesome time. So we spent over an hour. We still have a couple of minutes left. I will be able to finish it. I think we have just 5 or 6 questions left. All right, so see you in the next video. Right?